Hi and welcome. In this video, we are going to see about CodeChef October Long Challenge missing number problem. Okay, we are going to discuss what the problem was, understand the problem and see one of the implementation. Because why I am saying only one of the implementation, because this problem is based on implementation alone. Okay, this problem is dependent on how you implement it. On how you implement it, it will get accepted or rejected on the basis of how you implement it. Okay, it is a very simple problem to understand and the logic is also direct, but how you implement it is important. Okay, so I am going to show you how I implemented it. You can change it in whichever way you like. Fine. So let's begin with the explanation of missing number problem statement. So this is the problem statement. This is a story. The archaeologist John and his team have unearthed the remains of an ancient civilization. The partially destroyed walls of its house contains strange pair of numbers. John assumes that the first number in each pair always corresponds to a base itself written in base 10, and the second number in that pair is written in its base. For example, 3 and 2110 denote 66 in base 10. I will explain you how we convert any base into a base 10. Okay, what they are saying is the archaeologist John has found a house, an ancient civilization, in that on a wall some numbers are written, some pair of numbers are written. What are these pairs of numbers? The first one here is nothing but the base. The first one is base, okay, and the second one here is a number in a string format, okay. You can see that the number is in a string format with the input. We will read that line, okay. So now there is a base and there is a number. There is a base, there is a number. For example, base is 3 and the number is 2110. Base is 3 and the number is 2110. Okay. Unfortunately, the first number, the base, is often lost or unreadable. John made a list of pair of numbers found on the walls, where he represents the lost bases by -1. Now since it was old, so it is written that the base, some of the bases are lost. Some of the bases are lost. For example, I know that the number in is 10001. I know that the number is 10001, but I do not know its base. So therefore, John return is -1. I know that the number is 2110, and this time I know the base also. Okay. I know that the number is 18565, but I do not know the base. Therefore, -1 is written in the place of base. Fine. The next line is John is wondering if all these pairs of numbers could represent a single common number. Could represent a single common number. That is, if it is possible to choose some number x in decimal representation, that is base 10, and fill in all the bases in such a way that the second number in all pairs written on the wall when converted from bases to base 10 are equal to x. Now what is the meaning of this big? The line was big. What is the meaning? The meaning is there any number? Is there any number in base 10? In base 10, so that when we convert this number with some base into base 10, when we convert this number with some base into base 10, we get a number. For example, that number is x. Okay, can we get the same number x for all of these values? Can we get the same number x with for all of these values? I will explain this point in very detail. Let's just complete the problem statement. For each pair with a missing base -1 to y, we may choose any base from 2 to 36, and y is a valid number in base b. Okay. Now the important line here is John does not want to deal with huge numbers. He considered any number which is greater than 10 to the power of 12 in base 10 to be invalid. Okay. So there are so many possibilities. We need to find the smallest common number. We need to find the smallest common number. This was the question. Let me explain you the question with the help of the test cases that they have provided. Fine. So what is the input format? The input format is we have a t, that is the number of test cases, then the n, which represents the total number of pairs that we have. Okay, and in each line we get a pair, that is a base and a y. Now y is represented in a string format. Okay, and the length of the y can be 40. The maximum length of the y can be 40. Fine. Now let's move forward. What is the output? For each test case, print a single line containing one integer only. Okay, the smallest possible number x, or -1 if x is not present. Fine. Now what are the constraints? This t value can be maximum 200, n can be 100, base can be 2 to 36, or base can be -1. Y has digits from 0 to 9 and letters from A to Z. I will explain you this point. Next one is y length can be at most 40. Fine. So let's see the example now and let's understand the question from the beginning. So we have two test cases. This t value is 2. In the first test case, n value is 3. That means we will have 3 pairs. Okay. What are the pairs? Pairs are -1, then it is 10,000 in string. Okay. Now 8, then 20, and -1 and 16. So can we find a number x in base 10? Can we find a number x in base 10 which, when converted from this number with some base, I do not know the base, becomes all of these x's should be same. Now what is the meaning again here is, if my base of 1000 is 2, if the base is 2, then it can be converted into 16. Okay, 20 of base 8 is nothing but 16 in base 10. 16 in base 10 is nothing but 16 in base 10. So for these values, for the base 2, for 10000, 8, 20, and 10, 16, for these values I get an x which is common. I get an x which is common, that is 16. If I convert 10000 which is in base 2 in a number of base 10, I will get 16 as the answer. I will show you how do we get 16 as the answer. Okay, if I convert 20 in base 8 into base 10, I get 16 as the answer. If I convert 16 in base 10 into base 10, I get 16 as the answer. So we need to find such value. We need to find smallest such value. Okay, by getting the base of the numbers, that is -1, -1, by getting the base of these numbers such that we get the smallest common value. Fine. Let's see one more example, that -1 and 10100. Okay, -1 5a, -1 10111010. So we need to find first the base which we can use here. Okay, and when we convert this number of some base into base 10, we should get the same number. We should get the same number, not only the same number but the smallest same number, Okay, now in the example they have clearly provided that if this is in base 3, this is in base 16, and this is in base 2, and I convert each number into base 10, so I will get 90 here, I will get 90 here, and I will get 90 here. Okay, so 90 is the smallest common value possible when the base of the first number is 3, the base of the second number is 16, and the base of the third number is 2. When we convert them into base 10, we get 90. Okay, so 90 is the answer. We need to find this value. Okay, and to find this value, we need to find these bases. Which are missing. Okay, so this was the question. Fine. What we need to find? We need to find the value of x, which is a smallest common possible value, when we substitute some base value in the place of -1. We need to find such bases. Which, when converted into the normal base 10, gets our common value. And we need to print that common value. This was the whole question. Okay, now let's see step by step how we will proceed further in the question. Once we understood the question, now how we will proceed further with the question, that is how we will create our logic. Once we create our logic and handle the test cases, the corner test cases, then we can move on to the implementation part. Okay, so now let's look at the base. Okay, so the possible values of base are 2 to 36. Okay, now what is the meaning of this? When we have a base 2, the values in the base 2 are nothing but 0 and 1. I hope you know this. For base 3, the values are 0, 1 and 2. For base 4, the values are 0, 1, 2 and 3. For base 5, the values are 0, 1, 2, 3 and 4. Okay, if we start from 0 only. Okay, for base 9, Similarly, we have all these values. Now for base 10, for base 9 it is 0 to 9, 8. Okay, for base 10 it is 0 to 9. For any base, the values will be from 0 to base minus 1, to base minus 1. Okay, now for 11, it is given that from 0 to 9 it will be 0 to 9, and from as soon as we get to 10 it will start with ABCD. It will start with ABCD. So 11, base 11 contains 0, 1, 2, 3, 4, 9 and a character A. Okay, now A represents here 10. A represents here 10. Okay, 12 will get 0 to 9 and A and B. Fine. 13 will get 0 to 9 and A, B, C. A, B, C. Okay. Similarly, 15 will get 0 to 9 and A to F. A, B, C, D and E, not F. 16 will get F. Okay, this is a hexadecimal number. This is an hexadecimal number, that is 0 to 9 and A to F. Fine. Similarly, 36 here is 0 to 9 and A to Z. 36 here is 0 to 9 and A to Z. This is what they have provided us, that we have 0 to 9 and A to Z. Okay, you can see this point here. It's very clearly written here. Y contains only digits 0 to 9 and letters A to Z. Okay, here describing a pair of numbers found on the walls in the string Y, digits 10 to 35 in base 10 are represented by A through Z. Okay, so we started with 10A, 11B, 12C, 14D, 15E, so on. We'll go till 35Z. Okay, 35. So from 35, correct, 0 to 35. So what is the base? Base is nothing but 36. Fine. So let me just write it down properly. So since I told you this one, 0 to base minus 1, so we are till 0 to 35. So what is the base here? Base is 36. Okay, so 36, from now the base values are possible from 2 to 36. Base values are possible from 2 to 36. Now if the base value is given to 1, if the base value is given me that the base value is minus 1, so how many possibilities are there? How many possibilities are there to change this? So I can replace it with 2, I can replace it with 3, then 4, then 5, then 6, then 7, then 8 till 36. This minus 1 can be replaced for total 2 to 36, that is 35 values. In total 35 values we can replace this minus 1. Okay, I hope you understood this point. Fine, what are the bases that they have provided to us? Now let's move forward. Now let's see how do we convert into a decimal form, into a decimal base. So if I given a number in some base, how do I convert it into a base 10? Okay, let's see some simple examples. If the number is 101 in base 2, how do I convert this number into a base 10 number, into a base 10 number? So it is very simple. So from the end, 1 into 2 to the power of 0 plus 0 into 2 to the power of 1 plus 1 into 2 to the power of 2. Okay, so it is nothing but 4 plus 0 plus 1, it is nothing but 5 in base 10. Okay, it's that simple, guys. So if the number is ABC in some base x, what we need to do is c into x to the power of 0 plus b into x to the power of 1 plus ca into x to the power of 2. Similarly, if we have more than 3 numbers, that is a, b, c, d, e in some base x, so it is nothing but from the end e into x to the power of 0 plus d into x to the power of 1, so on till a into x to the power of 4. Okay, this number will be in base 10. This number will be in base 10. This is how you convert any number in any base into base 10. So for example, if I have 6a in base 16 and I have to convert it into base 10, so how do I convert it? It is nothing but 6 into 16 to the power of 1 plus a into 16 to the power of 0. Okay, so it is nothing but 6 into 16, 6 into 16, whatever the value is, plus 1. This is the base 10 number. Okay, what, just multiply and add it. This is the base 10 number. Okay, so this is how we convert any base any number in any base into a number of base 10. Okay, because this is required in our question. Now while conversion, the conversion of any number into base 10, the conversion of any number into base 10 depends on, this happens a loop, this happens in a loop, that is first 10 to the power of 0 will be multiplied by the last number. Okay, then the loop will iterate, the sum will be added. I hope you know the logic of the loop in conversion of base. So it depends on the number length, it depends on the number length. Okay, so if my number is of length 5, if my number is of length 5, then the loop will run 5 number of times. If my number is of length 3, then the loop will run 3 number of times. If my number is of length 2, then the loop will run 2 number of times. Okay, so just remember it. Okay, it is an important point, so just remember it, that when we convert any number into base 10, the complexity of that conversion is nothing but number length, is nothing but number length. Okay, the length of the number. Fine, now let's move forward. Now let's move forward and see some more points. Let's take some test cases. Okay, if my test case is 3 minus 1, that is I have 3 pairs, minus 1 101, okay, minus 1 100, minus 1 now for example I have, what should we take? Okay, take just simple 1011. Okay, we will keep it simple for now. So now what we need to find a number in base 10 which is common in all these, I do not know the basis of these numbers. Okay, so I want a number in base 10 which when converted is common in all these. Okay, so what can we do? How can we start? So the simple approach we can think of here is that we have a base from 2 to 36. If I convert my first number, I do not know the base, so if I convert my first number in base 2, I will get some answer. If I convert the first number in base 3, so if I convert the first number in base 3, I will get some answer. In base 4, I will get some answer. So in total I will get 35 numbers. In total I will get 35 numbers. So if my number 101 is in base 2, for example, let's just take an example. If it is in base 2, so convert 101 in base 2 to a number in base 10, so that will be 5. So 101 in base 2 is 5, store it somewhere. Okay, so 101 in base 3, so convert it in base 3. So in base 3 I think it will be nothing but 3 square, that is nothing but 9, 9 plus 1, that is 10. So in base 3 this number is nothing but 10. That means 101 in base 3 is 5 in base 10. Okay, 101 in base 3 is 10 in base 10. Fine. So for example, if we have 4, so just convert it. 4 square is 16, 16 plus 1 is 17, so it will be 17 in base 10. Okay, for 5 similarly 25, 26 in base 10. Okay, so this is how it will go on till how much? 35. Till 35 it will go on. So for this number I found out that I do not know the base, but the possibilities of base are just 32 to 36, that is nothing but just 35 numbers. So inside a loop that runs only 36 number of times, I can get all these possibilities. Correct? Similarly, the same thing I can do for 100 also. 200 in base 2 is nothing but 4 in base 10. 100 in base 3 is nothing but 9 in base 10. 100 in base 4 is nothing but 16 in base 10. 100 in base 5 is nothing but 25 in base 10, and so on and so forth. Correct? It will move on. Now same for 101 I can do this. Same for 1011 I can do this. So 1011 in base 2 is nothing but I think 11 in base 10. Okay, it is nothing but 11 in base 10. Then same for base 3, it will be some number which is nothing but 3 cube, that is 27. 27 plus 3 is 30, and 31 in base 10. Okay, let me just check it out. So 1011 is nothing but 3 to the power of 0, 3 to the power of 1, 3 to the power of 2, and 3 to the power of 3. That is nothing but 3 to the power of 3 into 1 plus 0 into 3 to the power of 2 plus 1 into 3 to the power of 1 plus 1 into 3 to the power of 0. So it is nothing but 1, it is nothing but 3, this is 0, and this is nothing but 27. So yes, it is 31 in base 10, and so on. So once I find out that for 101 I have total 35 values, from base 2 to base 36 I have one value each in each base, and for 100 also I have these values, for 1011 also I have these values. Then what I can do is I just have to find a value which is common in all these, and that should be minimum. If there are more than two values that are common, I have to choose the minimum value. If there are more than two values, more than one value which is common, then I just have to choose the minimum value. If my value that is common is for example, just start example 17 and 18, they both are coming in all these three storages, or we can say arrays. So what we can do is we just have to select the minimum one. So this is a possibility. This is a possibility of one approach, isn't it? What simply I have to do is convert each number in all the possible bases, which are just 35, okay, and then just check the common numbers, and from those common numbers check the minimum number. Okay, so first step is we can convert, then find the common numbers, and then find the minimum in those common numbers. Find the minimum in those common numbers. So this is one of the approach. This is one of the approach. Now let's see what will be the complexity of this approach. Let's see whether we can move forward to implementation part with the approach we just discussed. Okay, let's move on. I hope you understood this approach. It is a very basic approach. Okay, so how to check the complexity? So let's see. We have test cases which in the worst case can be 200, correct? The number of pairs in the worst case can be 100. Okay, we know that we have 35 number of bases, and to convert each number into a base 10 number, I have said that it depends on number dot length. It depends on number dot length, that is the length of the number, correct? So in the worst case, the length of the number which is provided to me in the form of a string is given to me as 40. At most the length of the string is 40. So at most the length is nothing but 40. Okay, so in the worst case, the time that my code right now will take is nothing but 200 into 100 into 35 into 40 in the worst case. Okay, so it is nothing but 2.8 into 10 to the power of 7, which is very well accepted in 1 second, So we can move forward with this approach, but we need to be smart with it. Okay, you cannot do that. For 100 elements you will form 100 arrays, okay, and in those 100 arrays you will find the common element, fine, and in that common element you will find the minimum element. No, the time complexity will be huge in this here. Okay, don't do this. The space complexity, time complexity, everything will be huge. Fine, we will be smart with it. Okay, we will use some data structures which is helpful in these cases. For example, we will use set and we will use map, okay, which are useful in these cases. We will use these data structures to implement, okay, and our time and our complexity will remain inside 1 second. The time complexity will remain inside 1 second. So yes, we can move forward with the brute force approach. But we need to be smart with our implementation. This question is only based on the implementation part. Okay, how do you implement it is important here. Okay, how to implement this problem is important. Okay, let's see some cases here and there, and then we will move on to the implementation part. Okay, there are some cases remaining still. Now what are the cases? For example, in my test case it is given -1 AA. In the test case it is given -1 AA. So as you know that for a base possible values are 0 to base -1, 0 to base -1. Okay, so a here, this one, can it be available for the base 0 to 10? Because for base 2 to 10, because for base 2 the possible values are 0 and 1. For base 3 the possible values are 0, 1, 2. I have explained you this point. For base 10 it is 0 to 9, but for base 11 now a arrives. So this a is not possible from base 2 to 10. Okay, it is only possible for the bases 11 to 36. 11 to 36 contain an element known as A, okay, but 2 to 10 does not contain this element. Okay, so we have to handle that. You do not have to check for A, you do not have to start converting from base 2, 3, 4, 5, so on till 10, then 11, so on till 36. No, these are not required. These are not required. So for every element, for every string, we need to check what is the minimum base possible. What is the minimum base possible, and we need to start converting from that base. We need to start converting from that base. So AA will start converting from base 11 to base 10, then base 12 to base 10, then from base 13, so on till base 36, so on till base 36 to base 10. Okay, so this was an important point. How you will do this? It's very simple. Just get the character which has the highest maximum ASCII value. Just get the character which has the maximum ASCII value, that is the largest character. That is the largest character. If we have the largest digit, that will be 9. If we have the largest character Z, so in a string just find out the largest character. Okay, and the base will start the largest character plus 1, and the base will start largest character plus 1. For example, A represents here 10. Okay, not ASCII values, sorry, these values. A represent here 10, B represents 11, C represents 12, 13 represents, sorry, D represents 13. So what do we need here is just find out what is the maximum value. What is the maximum value in this if my string is nothing but A, B, C, D? If my string is A, B, C, D, the maximum here is D, which represents 13. So our minimum base will start from 13 plus 1. Our minimum base will start from 13 plus 1. So A, B, C, D, the minimum base here will be 14. The minimum base here will be 14, and it will go on till 36. Okay, so for any string, find out the maximum element, and the minimum base will start from the maximum element's value plus 1. From the maximum element's value plus 1. Okay, this was an important case here. This was an important case here. Fine. Now let's see a pseudo algorithm for this question. Okay, how do we move forward in this, and then step by step we will see what we have to do in the implementation part. Now before we go any further, there are some other cases that we need to handle. What are these cases? Now during the conversion, if my string is A, B, C, D, E, F, G, H, I, and I have to convert it, there is a possibility that when converting this number from the maximum value is I, so it is 10, 11, 12, 13, 14, 15, 16, 17, 18, from 19 to 36, from 19 to base 36, during conversion the decimal number that arrives is greater than 10 to the power of 12. There is a possibility that if we convert a string, not this string, any string, that decimal number can be greater than 10 to the power of 12. In that case, we need to write -1 in that place. Okay, for 36, if it is greater than 10 to the power of 12, just put -1, because he considers x to the power of 10 to the power of 12 to be invalid. Obviously, during conversion, if it goes beyond the range of 10 to the power of 18, we can also have a negative number. Because after 10 to the power of 18, long will not be able to handle it. Okay, in C, C++, long, in Java, long. So if my value is less than 0, then also we need to have -1 in that place. So these two cases that we need to handle. These two are the cases that we need to handle. Okay, now let's see that if in the test case only, let's see if the two test cases that they have provided. The first one is 3, -1, 1, 1, 0, 1, 0, 0, and 8, 20, -1 and 16. So for this 10,000 and 16, we have in total how much? In total we have 2 to 36, that's 35 values. For 10,000 also we have 35 values, and for 16 we have from 7 to 36. Okay, there is nothing but I think 30 values. Okay, but for 20 we do not have any choice. We just have a single choice. We have to convert 20, which is in base 8, into base 10. We have to convert 20, which is in base 8, into base 10. We do not have any other choice. This is nothing but 16. This is nothing but 16 in base 10. So you do not have any other choice to convert this in 16. Okay, so if we get this 16 in anywhere in 1000 and 16 anywhere in here, so we will get our answer, which is provided to us. So if we have a base, which is not equal to -1, in that case we just have a single option. Okay, and if we have a base which is equal to -1, then in that case we have multiple options. Okay, so we have to divide our code in such a manner. Okay, so how can we divide our code? Let's see that. So here what can we do is, in the first step, we just take all the inputs. Okay, what you guys can do is, you can also map the characters from 0 to 9 with the values of 0 to 9. So these are the characters from 0 to 9. You can map from integer values, that 0 represents 0, 1 represents 1 in integer. Okay, using a hash map. And from A to Z we can simply use 10 to 35, sorry. Okay, from A to Z we can use this, that is 26 characters. A represents 10, B represents 11. We can map it in the first step. We take inputs and do the mapping. Now in the second step we can implement simple our conversion logic. Okay, how you will convert. Now during conversion we need to take care of these all points that I have explained here. Okay, that if the number is greater than 10 to the power of 12, then return -1. If it becomes less than 0, then return -1, and so on. In the conversion logic we need to take care of that. Now for each pair that we have taken in the input, okay, if the base that I get is not equal to -1, that is nothing but this case, then what we need to do, we need to have a different logic. We need to have a slightly different logic. Okay, else if the base is actually equal to -1, if the base is equal to -1, not 1, -1. Okay, just write it down, it is -1. Okay, if base is equal to -1, then it's logic. So if the base is not equal to -1, then the logic for that, and if the base equal to -1, then the logic for that. At the end, just compare all the values and print the minimum one. Compare all the values, get the common values, and print the minimum one. Okay, now the important point here is these two logics. Now here I am going to use hash map and hash set. Fine. So let's begin. First we will see the base is not equal to -1 case, and then we will see the base equal to -1 case. Okay, and then at the end we will see how we will get the maximum value. Fine, so let's begin. So let's begin with the case when base that we have is not equal to -1. For example, they have provided me with 11a. So let's see what we will do. In all these three cases the base is provided. We will go one step by step. So in all these three cases the base is provided. So if the base is provided to me, that is it is not equal to -1, so first step is simply convert the string that we have in base 11 into base 10. Check if it is greater than 10 to the power of 12, if it is negative or not. These two checks needs to be made. Okay, second is in a hash map. Now a hash map contains a key and a value pair, okay. So whatever value that we get after conversion, so 11a in base 11 is nothing but 10 in base 10, okay. So how will we convert it? So how do we convert it? A in base 11, correct? So it is nothing but a into 11 to the power of 0, which is nothing but a into 1. What is a? A is nothing but 10. So 10 into 1 is nothing but 10. So a in base 11 is 10 in base 10. So this make the converted number as a key, okay, and increment its value, that it has occurred one time. Okay. Now go to the next one. This is also do not have any choice. We have to convert it in the given base only. So a in base 11 is nothing but 10 in base 10 again. So just check, is it already present? Yes. If it is already present, increment its value. Okay. Similarly for the third case, it is same, so increment its value again. Finally, in the hash map, what we have a value that is 10, which is coming n number of times. That means 10 is repeated for all these three values. 10 is repeated for all these three values. So print it. So simply print it. We just have single common element. We just have single common element. So if when my base is not equal to -1, it's very simple. When my base is not equal to -1, it's very simple. It is not the case that I'm talking that all the bases are not equal to -1. If my base, even if a single base is not equal to -1, we have to follow this step. For example, it is -1a, okay, and 11a, if this is the test case. So this part will follow the case of base equal to -1, which we will see right now. Then this second part will follow, which we have seen, base is not equal to -1. Okay, first part will follow the condition base equal to -1, and the second part will follow the condition base not equal to -1. Okay, so if we do this, we will do this after we just learn about the case when base equal to -1. So now we will be seeing what will happen if the case is equal to -1. For example, let's just take a simple example for this and move forward. So for example, we are taking that it is -1 AA, okay, then -1 AA, okay, and then 11 AA. If we are taking this case, okay, so the first and the foremost thing is get the maximum character. Which is nothing but A. For each pair we need to get the maximum character. So first we are accessing the first pair, so get the maximum character of the string, which is A. So the base will start from 11. And go to 36. So this is our loop. Okay, first is get the maximum base, the first step. So the first step is get the maximum character so that we can get the base value to begin with. Okay, now the second step is from 11, from the maximum character plus 1, to 36, one by one start converting the base, start converting the value. Once we convert our value inside here only. Okay, now here we have two things. We have a set, and we have a hash map. Okay, this is the same hash map that we will have in the case when base is not equal to -1. Okay, so this has a key and this is a value. Why we are using set, I will just explain you that point. So once we start converting, so A will be start converting. So A in base 11 is nothing but 120 in base 10. It is nothing but 120 in base 10. So in the set 120 will be added. In the hash map 120, and the value will become 1. Okay, in base 12 I think it is 130. So this will move on for all the 36 values. We will have in the set all the from 36 minus 11 plus 1. How much it is? It is nothing but 26. So we will have all the 26 values in the set, and we will have the values in the hash map also. Okay, so here we will have 26 values, and here we will have 26 values. Each value will be added first time, so the value will always be 1 for all the 26 keys, okay. At the end we will end this, that is all the 36 are over, fine, and then we will move on to the next pair. Now in the next pair again we will move on from the beginning, of our outer loop. It will check if the base is equal to -1 or the base is equal to not equal to -1. Okay, in that beginning what we will do is we will clear our set. So the set currently contains nothing. Okay, now AA will come, and again all these values will come here, and this will be incremented by 2. Everyone will become 2. Fine. Now when this AA comes, we will go into the case of base equal to 1. The case of base equal to 1. I think it's here. Yes, when the base was not equal to -1 in the case of 11 AA. Fine. Here these two steps will run, and in our map, wherever the value of 120 is there, that will be incremented to 3. Okay, only 120 value will be incremented to 3. Okay, so in the map, which value is incremented to 3, that is equal to the number of pairs that we have, that is equal to n. The number of pairs that we have is only 120. is only 120. So therefore in the final answer we will print 120. I hope you understood this point. I hope you understood this point. So we have two cases, base equal to -1 or base not equal to -1. We have how many cases? Two cases. Fine. Now why we were using set is, why we were using set here, it's very simple. So in the case when we have a number, for example AB, okay, and we are checking this number for 12 to 36, I hope you know now why 12 to 36, and the same number appears again, and the same number appears again. For example, for 12 to AB the value was 6, and for 27 also the value was x. Okay, for 27 also the value of x. Now we do not have to increment x here two times. We do not have to increment x in our hash map two times. Okay, because in the hash map only we are checking whether the number is exactly equal to n or not. Okay, whether the value is exactly equal to n or not. We do not want the x, the same number, to be incremented twice for the same pair. For the same pair we do not want the same number to be incremented twice. Therefore we are using set. The use case of set is, in the set all the numbers are unique. All the numbers are unique. Okay, now if the set says me that x is already present, then I will not add x here, that is I will not increment the value of x. I will not increment the value of x anywhere in our hash map. Okay, it will be just incremented once for a single pair. Okay, this was the use case of set. Now you can implement it any way you like. You can implement it any way you like. Fine. So here you understood what was the use case of set. You understood what is the use case of hash map. I have explained you with example that what will happen in the case of base equal to -1 and what will happen in the case of base not equal to -1, and how they are both satisfying the conditions. Also how they are both are using this hash map. How they are both using this hash map to get the value that we need. Now if in this hash map we have two values, x and y, or three values x, y, z with the same value, okay, three keys with the same value, then what we will do, we need to find the minimum between these three keys. We will iterate over our hash map, and we will find the minimum between these three keys if the keys have the same values. Okay, because we want to find the smallest possible number which is common in all the pairs. Okay, smallest possible number which is common in all the pairs after we convert them into base 10. So this was the whole question. This was the whole question. Therefore the implementation of this question is lengthy because there are so many cases here that we need to handle. There are so many cases here that we need to handle. Okay, so I hope you have understood why I am using hash set and hash map in this case. Okay, I will be showing you the implemented code, and in that code I will tell you what does block do. Okay, there is a block which convert, there is a method for conversion. Okay, there is an if block for equal to -1, there is an if block of not equal to -1. Okay, and finally there is a for loop block that will find me the minimum answer. There is a for loop block in the end. Fine. So let's see all these points. In the implemented code. So this is the code. Okay, first the test case, a value. Why this value? This is a hash map for just you converting that 0 character is value 0, 1 character is value 1, 9 is 9, a is 10, okay, b is 11. I have explained you this point, correct? So this is the hash map for that, the implementation of the hash map for that. Fine. So what we are doing here, so here it is nothing but mapping character to its value, character to integer value. Fine. Till here we are doing this part. Now this is max limit, that is the maximum value allowed. If anything crosses this value, we have to just simply do -1, maximum value allowed. Fine. Now here the test case loop will start. This is nothing but the test case loop. Okay, now first is the input n, that is the number of pairs. Then here it is a value map. What it is nothing but a hash map. What this hash map will do, we will see. What is this? This is nothing but the base array. Okay, this is nothing but our string array. Okay, that is nothing but base string pair that we have. We are taking the base string pair input here, okay, input of base string pair, fine, and storing it in their respective arrays. Okay, then we'll move forward. Now here what we are doing is, in this one, let's see what we are doing in this one. So what was this hash map? The map that is storing our key values, map for key values that I have explained you. Okay, now here this is the set. As you can see, whenever the loop start, a new set will be created. Okay, this is nothing but what I have explained you. Whenever we iterate back, we have to empty our set. Okay, so this is our set. Now what we are doing, we are accessing the pairs one by one. Okay, so this is the base, first base, and this is the string value. Fine, we are accessing the base and the number one by one. Now this, what we are doing here is the condition when base is not equal to -1. Okay, the condition when base is not equal to -1, that is base is not equal to -1, the condition is this for this part. Fine, for this part is base equal to -1. Fine, this is the condition for the base equal to -1. Fine, why else is not used? Because I'm using continue, so after this it will just continue if it comes back here. Okay, so now what we will do back, so yes, in base equal to -1, now this is nothing but the conversion. This is nothing but the conversion. I am converting using a function, the convert base function. Okay, that function is implemented here. This is the convert base function. As you can see, whenever the answer is more than the maximum long value return 1. Whenever the answer is greater than the maximum long value, return 1. Okay, you have to check that. Now when we come back here, here not equal to -1. So if my answer, that is the answer, is less than 0 negative, then also you do not have to do anything, continue. Okay, if the down here I am just storing this key and incrementing the value. If it is first time that I am storing, then the value is 1, and if I have stored it before, then in the previous value add 1. Okay, now move forward. In the base equal to -1, first we need to get the maximum value, that is the value that I have to begin with, the max value. I have to get the max value. Okay, if it is a b c d, then d is the maximum, so we have to begin our loop here from max value plus 1. I have explained to this point, and we have to go till 36. Okay, now again this is the conversion logic, and this time we will convert one by one from the base j, that is max value plus 1, till 36 we will start converting. Okay, this is the same code that is above. Then we will check if it is less than 0, then continue. Now here what we are checking is, if the set already contains this value, then do not add it in the map again. Okay, if the set already contains this value, do not add it in the map again. Okay, what the contain function returns is, if it is added, it will return true, and we will run continue, and we will loop back. Okay, now if it is not true, then we will add into our map. So this is what we are doing, adding into our map. Okay, and finally add that into our set also. Fine, now when this loop is over, we will loop back here. Again the set will be emptied, so there is a new set will be created, and the same process will run again, and the same process will run again. Finally what we are doing is, we are getting the minimum value, and we are printing the answer. Okay, so what is max limit? That is 10 to the power of 12. So if the result is that big, then -1, else simply print the result. So the implementation part totally depends on you guys. Okay, whatever way you like, you can implement this code. Whatever way you like, you can simply implement this code. Okay, the important point was to understand how do we reach here. In this program, the most important point is implementation, because we know that the brute force will be applied, we know what we have to do, but how do we do this, how do we implement this? Okay, that's why this was a good question in October long challenge. Okay, now once you submit it, it will be accepted. Let's see that. So once you copy paste the same code and click on submit, it will be accepted. Okay, this is the same code that I have shown you there also. Fine, so this was the missing number problem. Okay, MSNG, the missing number problem. Fine, so you can implement it as you like,